Oh, that's going. I'll go back here and go like that. Notification is there. We're going to go ahead and open that. All right. So this is the next installment for today's lecture. We are moving on to section 3.5, rational functions graphs. Now this section typically gives students a hard time. We'll do a couple of examples. This section, I think it'll probably be easier to just kind of work examples. Trying to explain all the nuances is information overload. This typically gives students a hard time. So you do have to kind of have a fresh mind and do the best you can. I'll work a few examples. I'm just going to devote 30 minutes. I'm just going to devote 30 minutes to this section. So wherever we stop, that's where I'm going to stop and leave the rest in your hands. I'm going to let that be. Let that be. That's not necessary. Reciprocal function. That's fine. No. This will come out as we start to work examples. I would rather just work some examples. So we're asked to graph this. It says give the domain a range. All right, so when I'm graphing a reciprocal function, it's similar to how we did polynomials with a few added part components, right? So the first thing I look for, I still start with my intercepts. Let me see. So first we'll do intercepts. And let's start off with the Y-intercept. If we're going to find the Y-intercept, what do? Set. If we set x is 0 in this original, what happens? Negative 2 over 0, which is, remember, some number over 0, you want to knock that out, KO. That's undefined. But 0 over some number, this is okay. So this is equal to 0. So do we have the KO or do we have the OK? We have the KO. So that means that this one is going to be undefined. So there's no Y-intercept yet. So when we set x to 0, it's undefined. So we're going to say there's no Y-intercept. So we're going to say none here. Okay. Let's see. So we can talk about the Y-intercept, then we can also talk about the X-intercept. Now, when is a fraction X-intercept? What do we need to do? Set y equal to 0, right? If we set y equal to 0, now we have a fraction equal to 0. When will a fraction be equal to 0? When the top is 0 or when the bottom is 0? When the top is 0, right? So if we set will the top ever be 0 in this case? No. So is there an X-intercept? We're going to say none. There's nothing you can plug into the top. So let me back up here. So a fraction being equal to 0 means set the numerator to 0 and solve. If we set the denominator to 0 and solve, there's no solution. So there's no X-intercept, or none. So now, if we can set the numerator to 0, then we can do what? Set the denominator to 0. That's the next natural flow. I know we've already done it, but I'm saying this is how the flow goes for this. So then the third thing is set the denominator equal to 0. If we set the denominator equal to 0, what x value gives you 0 there? X equal to 0, right? So x equals 0 is going to be our, anybody know what the graph, how this graph is going to look when we divide by 0 in this context? So when we divide by 0, the graph is going to be a vertical asymptote. It's going to be a dashed line, and that means in the long term, we're going to get really, really close to this dashed line, but we're never going to touch it. That's a vertical asymptote. So when we have some number over 0, that's a vertical asymptote. This one here, this is the vertical asymptote. This one. But there are some times when we get 0 over 0, this is actually going to be a hole or a gap in the graph. This is a hole. Anybody see the movie Holes of Stanley Yelnats? That's what this is. That's what this is. There's either going to be a hole or a gap in the graph. This one. That's what this means. So the double 0 is just a hole or a gap. But if you have, sorry, I got it mixed up. Right here. This is the vertical asymptote. Let's get rid of this. This is the vertical asymptote. So when we divide by 0, some number over 0, that's the vertical asymptote. But 0 over 0, that's going to be a hole or a gap in the graph. So that means we have a vertical asymptote when x is 0. So now, if we could talk about vertical asymptotes, we can also talk about, You know any other kind of asymptotes that we can talk about? Horizontal. Horizontal. You're still doing it. Like, you don't notice the attention that you get? Come on, you do this all day. It's so funny. But I give you the same attention. I got to do something different. But anyway, I need somebody to start attendance, like a sheet with today's date. So we can talk about horizontal asymptotes. So then number 4, we can talk about horizontal. Now I'm giving you a crash course. This should, yeah, it's all recorded. Yeah. Now I'm giving a crash course on this, but you know these topics should pop up throughout this section. I'm just giving you an overview. I'm just giving it all to you from the rip. So now to find the horizontal asymptote, we got to do. There's 3 tests. We look at the degree of the numerator, what versus degree of the denominator. What's the degree of the denominator in this case? What's the highest exponent in the denominator? 1. Can somebody tell me the degree of the numerator? It's 0. The degree of a constant is 0. So because the degree of the numerator is less than the degree of the denominator, that means the horizontal, this should pop up a little bit later. The horizontal asymptote is going to be y equals 0. So we're going to have this line y equals 0. In the long term, you can cross the horizontal, you can touch the horizontal, but in the long term, you should stay close to the horizontal asymptote. Okay. So if we have a horizontal, there's no slant. And then lastly, the 5th thing is we would do is find a few additional points. So I'm going to say a few additional points. We'll do a few additional points between them, beyond the X-Intercepts and the asymptote, the vertical asymptotes. And then we will put it all together. For instance, what I mean by the few additional, so if we look at the number line, the X-Intercept, we don't have an X-Intercept. We do have a vertical asymptote, is x equals 0. So the only key number here is x equals 0. So we're just going to choose a few points on either side of this. Give me a number to the left of 0. So when x is -1, what's the y? If we plug -1 into the original, what y value do we get? +2, right? Double negative is positive. When x is -2, what y value do we get? 1, right? Let's go ahead and do one more. When x is -4, what y value do we get? A half, right? What about on the right-hand side? Now, we didn't talk about symmetry. We do have symmetry here. That's actually my number 5, but I'm going to leave it like this. This is enough. So when x is 1, what y value do we have? Well, what y value do we have? Negative. When x is 1, y is... Shoot. Give me... Oh, no. Is that going to mess up my recording? It's going to have to be okay. Give me a second. It should be okay. So when x is 1, y is going to be -2. So I know this is a lot. You just kind of have to work it. You just kind of have to keep working examples. All these concepts that we're exploring, they're listed out throughout this section. So I'm just kind of going through all of it with each example. And I'm going to limit it to 30 minutes. All right. So that should be enough power. Hopefully everything should pop back up without skipping a beat. There it is. Okay. So when x is 1, y is -2. When x is 2, y is what? -1. And then when x is 4, y is -1/2. Okay? So then we would just put all this together on a chart. So there's no y-intercept, no x-intercept. We have a vertical asymptote of x equals 0. Horizontal is y equals 0. And then, so it's going like this, and then like this. Okay, I see it. So if you plot those together, you get a graph kind of like this. You just you got a horizontal, we got the vertical. We plot those 6 points that we got, and when we plot them, we'll get something like this, and we connect them with the smooth curve in this fashion. So the reciprocal functions typically look like this. Okay, let's try another one. Again, this one always gives students a hard time. Don't feel bad. Students always have a hard time with this, at least with the way I explain it. And I don't always explain it this way, but it's just the nature of the beast. Let's just do another one. Let's just try another one. All right, and let's try this one from scratch on some clean paper. So we're gonna bookmark. Let's bookmark this for right now. We're gonna copy. Let's go back to the bookmark, and we're gonna Yeah, that's the last one. So we're going to paste. And this is the new one. Graph this, domain and range, increasing, decreasing, and all that. So let's get a copy. All right. And we're going to drop this right here. And like some of the institutions I've worked at, they complain and gripe about money. And I was like, dude, I've given y'all at least one solution, you know, for this whole money thing. And like they won't open their mind to like other solutions to generate income. I was like, well, as long as your mind is closed, then you're going to close yourself out from a possible viable solution. So while they're kind of still stuck and trying to do things the old way, I was like, you gotta embrace, you know, doing the same thing over and over and expecting a different result is the definition of insanity. To have something you never had before, you got to do something you never done before. So something different has to be done in order for the solution to come. Oh, I think I just added on to that. Something different has to be done in order for the solution to come. Anyway, okay. So we're asked to graph this. Now let's do our same little procedure that we did last time. The first thing we want to look at are intercepts. So first, let's go ahead and look at some intercepts. Let's start off with the Y-intercept. All right. To find the Y-intercept, what do we do? Set. If we set x is 0, what result do we get? When x is 0, can you see it? Let's copy. Let's paste. Let's edit. Let's crop. We want this. So when x is 0, what's our y? 2. Yeah, I was hearing everything except 2. That's gonna be okay, just like that. Let's hit done. So now you should be able to see it. Remove the excuses. Okay, that'll be fine. So when x is 0, y is 2. So we quickly got our Y-intercept. So if we could talk about the Y-intercept, we can also talk about the X-intercept. To find the X-intercept, what do? We set y to 0. When is the fraction going to be equal to 0? When the... So we're going to set... So for the X-intercept, we're going to set y equal to 0. In other words, set the numerator equal to 0. So would this numerator ever be 0? No. It's never going to... The numerator, we can't get it to 0, so there's no... So we're going to say none. No X-intercept. Okay? Now, if we can set the numerator to 0, we can also talk about setting the denominator to 0. Okay. So then we got d of x equal to 0. What is that going to tell us about the graph? What should it tell us? Vertical asymptotes. So setting the denominator to 0 is telling us about asymptotes. So the next category after intercepts are asymptotes. I'm assuming that I'm saying this proper. But you get my gist as far as what I'm referring to. So now, if we want to find the vertical asymptote, we got to find out what x makes the denominator 0. So if we set the denominator to 0 and solve, what's going to be our vertical asymptote in this case? X equals -1. So when x is -1, we should have a vertical bar. Now, if we could talk about vertical asymptotes, we can also talk about what? Horizontal. Do you see the flow? Is it catching? So now, to find horizontal, let me go ahead and list out the 3 tests. We got to look at the degree of the numerator. So if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is going to be y equals 0. That's the first test. The second one is, if the degree of the numerator is equal to the degree of the denominator, it's going to be the ratio of the leading coefficients, an over bn. Ratio of the leading coefficients. This test you're not going to know because I'm giving it to you. It should pop up somewhere in the section. I'm just giving it to you flat out. The third one, if the degree, I hope I'm not mixing this up. The third one should be if the degree of the numerator is larger than the degree of the denominator, there's no horizontal asymptote. There's an extension to that. I'll say 4. If the degree of the numerator is larger than the degree of the denominator by 1 degree, then we have a slant asymptote. a slant asymptote. And we'll talk about that as it arises. Okay? But for horizontal asymptotes, we have these cases that are going on that we need to consider. Now, this should pop up in this section. I'm just giving it to you right now. Confirm that this stuff works. So now, which of these cases do we have? What's the degree of the denominator in this case? 1. The 1 is right here. What's the degree of the numerator? 0, 0, because it's x to the power of 0. Constants have a 0 degree other than number 0. Okay? So now, are we talking about case 1, 2, or 3, or 4? Case 3, the numerator, no, the numerator is larger than the denominator? Which one is it? Number 2, the degree of the numerator is equal to the degree of the denominator? So which one is it? It's the first one. The degree of the numerator is less than the degree of the denominator. So what should be our horizontal asymptote? Y equals 0. So again, that's not obvious. I'm just listening. I'm giving it to you before it pops up. So the horizontal asymptote should be y equals 0. So if we have a horizontal, there's not going to be a slant. We could do a test for symmetry. I'm going to go ahead and add that in there. Number 5 is the test for symmetry. And all we do is replace x with negative x and see can we get back to the original. There's no symmetry here. I'm going to say there's none. Yeah, there's none. Because if we replace x with negative x, we can't get back any form of the original. So there's no symmetry. And then the 6th step is a few additional points. So the key numbers that you want to put onto this number line are the X-Intercepts and the vertical asymptotes. What's the X-Intercept? There's none. The vertical asymptote is x equals -1. This is going to be a vertical bar. So give me a couple of points to the left, a couple of points to the right. What's the x value to the left? -2. When x is -2, what's our y? -1, right? So -1. When x is -3, what's our y? I'm trying to give you plenty of time to get the answer before, instead of tagging on the end. So I keep trying to give out points, but I keep not doing it because it's so irritating. So I just don't give out the points. Don't tack on. That's so irritating. You know what you're doing. Yes, you are. Yes, you are. You know, because look, I do the same thing to my sister. I do it to my sister. Yes, you are. Look, when I give the answer, you're like trying to tack on to the end. I'm gonna keep picking on you as long as you do it. As long as I notice, I will pick on you. I will pick on you. Stop doing it. Don't do it. I will pick on you. I will pick on you. I will pick on you until you stop. Go ahead. When x is -3, we get -2, so that's a -1.
Oh my gosh.
Okay? So now when x is, give me something going to the right of -1. 0. We did 0 already, right? We did 0. So that's fine. Let's go ahead and do 1. When x is 1. When x is 1, what's the y? 1, right? Yeah, because 1 plus 1 is 2, so that's a 1. And then let's just do one more. That's fine. That's enough. We can do one more. When x is 2, what's the y? 2/3. Well, let's stop with the other one, just so we're not dealing with fraction. So now, this is all the information. This is all the information. So then we just put all this on a graph, right? The x values go from 3, the y's. So if we go about 5 in all directions, we can capture all of this. Let's go like 6 in all directions. Let's copy. Let's copy and let's paste. I'm going to clear. All right. So now let's go like this. Text box, space, go away, come back. Paper, graph paper. Okay, cool. So now, all right. So we said let's go like 6 or 7 in all directions. That should capture everything. So we're doing it manually, just so you can see that it actually works. And the time, we're still at 20 minutes, so we're good. Oh. All right. Okay, let's go like this. 1, 2, 3, 4, 5, 6, like that. And then 1, 2, 3, 4, 5, and that's enough. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's enough. So then this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. This is the origin. 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. 1, 2, 3, 4, 5, and 6. Okay. So now, the first one. We said the y-intercept is 0, 2. So let's plot that. 0, 2 is here. All right? 2, we didn't have an x-intercept. 3, we said a vertical asymptote when x is negative 1. So we're saying here, there's a dashed line like this. Okay? We didn't talk about, that's fine. It's not a polynomial, so we can't do that. Number 4, horizontal, we said y equals 0. So y equals 0 is this. So this is the horizontal. Number 5, we didn't say there's no symmetry. 6, we did a few additional points. We do have a vertical. So when x is negative 3, y is negative 1. So we're here. So this is negative 3, negative 1. We have negative 2. Wait a minute. Wait. Something's not right. Negative 3, negative 2 is negative 2, right? That's supposed to be a negative 2 right here, right? Because that's a negative 2, that's negative 1, that's a negative 2. So I think we had a mistake. But we fixed it. So when x is negative 2, y is negative 2. So we're here. This is negative 2, negative 2. We have the asymptote. That's fine. Then we have something on the right. And then we said 1, 1 is here. So now, with the asymptotes, all we do to graph, so now, if you see that these points are like in this region here, and these points in this region, we're pretty much going to stay there for the most part. So what we're going to do is the following. We can keep it as blue. So we're going to start, we're going to, come on. We're going to start close to the asymptote, pass through these points, and then finish close to the asymptote. That's it. Start close to the asymptote, pass through these points, and finish close to the asymptote. That's it. That's how you graph these. Let's undo. Let's just redo this one. Start close, pass through the points, finish close. Okay. So then let's go paper, this. All right. So that's the graph. So it's kind of the same thing. What's the time? We've been at it for about 20 minutes. So that's us doing it by hand. Let's do like this and copy and compare. Let's copy. We're going to paste, and we want to shrink this down to size because we want to compare it to the actual solution. Let's cut this. And we're going to paste. So we did it by hand without looking, and you see it matches. Questions, comments, or concerns? All right, we did this one. I'm going to let that be. Okay, if we have a graph like this, what's the domain? The very left to the very right. How far left does the graph go? How far right does it go? Are there anything unaccounted for as you go left to right? So I think this is a good time to use red. So now, if we're going left, far left, yeah, I can agree it goes all the way to negative infinity. Everything is accounted for. But as we come to the right, notice it is not accounted for when x is what value? What's this x value here? Negative 1. So it's undefined when x is negative 1. Then we jump over on the other side. Then everything else on the other side is defined. So the domain is going to go from negative infinity up to negative 1 with parentheses, and then union negative 1 to infinity, all with parentheses. You kind of see it here. It's a bit of a typo. We have a negative infinity to negative 1, union negative 1 to infinity. Okay? And the range does something similar. It goes down from negative infinity up to 0, but we jump over 0. It's the same kind of argument. Okay, let me look at this. I'll do one more from this section, and then the rest is going to be, the rest of this is up to you. I'm going to let this be. Let me just do one more example. Okay, well, they showed us the answer there. I mean, essentially, you can do this one the same way. Intercepts, asymptotes, symmetry, few additional points, graph. It's a lot. You just have to do the best you can. Again, if anything is not clear, if you email me, I can make dedicated YouTube videos. Again, students always have a hard time with this section. It's a lot. And these are my students that typically have the whole semester. They have a whole semester to look at this. You guys have a quarter. So that makes it even more challenging. So this is why I don't mind the notes being open, because it's so crunched. I want to work one more example. Yeah. Okay, so this is where we're getting into some of the asymptotes. We've mentioned it already. So the oblique or the slanted occurs when the degree of the numerator is larger than the degree of the denominator by 1 degree. Then we would do a slant asymptote. What's the degree of the numerator here? What's the degree of the numerator? What is it? 1. What's the degree of the denominator? If you were to FOIL this out, what degree would the denominator have? 2, right? So the degree of the numerator is smaller than the degree of the denominator. Okay, so based on what we said before, if the degree of the numerator is smaller than the degree of the denominator, what should happen? It should be y equals 0. Should be the horizontal asymptote. Are they doing it like this? Maybe I got it backwards. No, where is it? Yeah, there it is. Y equals 0 is the horizontal asymptote. Okay. What's the degree of the numerator here in part B? What is it? It's 1. What's the degree of the denominator? 1, right? So is it less than, greater than, or equal to? They are equal to each other. So we take the ratio of the leading coefficients. What's the leading coefficient of the numerator? What's the leading coefficient of the denominator? 1, right? So then the ratio is going to be 2 over 1. So then the horizontal asymptote is going to be y equals 2. Find all asymptotes. So the horizontal is y equals 2. Tell me about the vertical. The vertical occurs when what? What? If what's negative? Not negative. If the denominator is equal to 0. The vertical asymptote, so it's okay because we just introduced it today. I know it's a lot. So the vertical asymptote occurs when the denominator is equal to 0. What x value is going to make the denominator 0 here? 3. If we plug in 3, will we get some number over 3? I mean over 0? Yeah. So that means the vertical asymptote occurs when x is 3, horizontal is y equals 2, and I think that's it. X equals 3, and the other one should be y equals 2. Yeah, y equals 2. Okay, so we're about halfway through this. Okay, what's the degree of the numerator here in C? What's the degree of the denominator? So this is a case where the numerator is larger than the denominator by 1 degree. So this one, we should have a slant asymptote. To find the slant, we just divide. Polynomial long division. Or synthetic. In this case, we can do synthetic. If we do synthetic division, what goes in the chair? What's the 0 of the denominator? 2. Pen died already. So 2 goes in the chair. What are the leading coefficients of the numerator? Nope. Nope. So we have a placeholder here. So there's a 1, 0, 1. So 2 goes in the chair, then we have 1, 0, 1. Then, then you can do your synthetic division. Then we're ready to go. I could explain that. I'm not going to because it's going to make it worse. I'm just going to let it be. Right here. Here's the synthetic division. So when we do synthetic division, we get a remainder of 5. And then that x plus 2, that's the equation of the slant asymptote. So we're going to say y equals x plus 2. We graph that dashed line. That is the slant asymptote. You'll see it right. You'll see it right. They didn't do it? Are we just identifying the asymptotes? Let me see what the original. Oh, find the asymptote. Okay, so the asymptote here should be y equals x plus 2. You see it right there. Okay. So when the degree of the numerator is larger than the degree of the denominator by 1 degree, we divide, and then the quotient is the equation of the slant asymptote. Okay? Or the oblique. Okay, I'm going to let that be. I need to charge my pen, and we're at 30. Let me at least finish out. We're not going to be able to finish this out. So they found the asymptotes. So when they're graphing their rationals, they find any and all asymptotes and any and all intercepts. That's fine. It's another technique. So they find, now I usually go intercepts and I go asymptotes. I'll do a test for symmetry and then I find a few additional points. We've done at least 2 examples together doing all this. So you have to kind of go back to that. We'll make this the last one for this section, and then the rest is up to you. Okay? Let's do this one more time. So let's paste. We don't have it. Okay, let's go here. So let's find it somewhere. We can copy this one. Let's copy. Back to the bookmark. Here, we're going to paste right here. We would like to clear the page. And let's go ahead and copy the clear page. And let's paste. Let's also get a copy of the original. All right, so let's get a copy of this and let's shrink it down. So now we're going to try hand and graphing this manually. I know it's a lot. I know it's tough. You have to do the best you can. All right, then let's take some time to answer some questions after this. So we'll do this one. We're going to take it, drop it here. We want to cut. We're going to start here. Paste. Okay, so first order of business, let's look at some intercepts. Oh, I got to charge my pen. So give me a moment. So yeah, 15-second charge with this device is supposed to charge it for 30 minutes. It's supposed to hold the charge for 30 minutes. I think I mentioned that before where, yeah. So I'm going to just let it sit for a few more. Huh? Well, I'm saying as far as like an opportunity for somebody. If somebody can figure out batteries that charge really quickly, if you can create a battery that charge, like where, think about how long it takes us to charge our devices. Imagine if you had a device that charged in a matter of minutes or a matter of seconds. Could you, what does it take? What does it involve for something to behave like that? It's pretty good. Okay, let's look at it. So it should come back up. So now, let's start off with some intercepts. Okay. So if we're going to start with intercepts, we typically start with the Y-intercept. What do we do for the Y-intercept? Set. Okay. So we're going to set x equal to 0. If we set x to 0, what does the top become? And the bottom is this. So the Y-intercept is going to be 0, negative 1/3. Right? So now if we could find the Y-intercept, we can also find the what? Walk me through it. So what do we do? So to find the X-intercept, we set. We're going to set y equal to 0. But when is a fraction equal to 0? When the numerator is equal to 0. Fraction is equal to 0 when the numerator is equal to 0. Okay? So if we set the numerator to 0 and solve, we get x plus 1 equal to 0. X equals. So the X-intercept should be negative 1, 0. Okay? So we're building a case. So now, if we can set the numerator to 0, naturally we can set what? If we can set the numerator to 0, we can then set the denominator to 0. And this is going to tell us about what? Denominator. Asymptotes, okay. There's an E on there. Okay, so then if the denominator is 0, provided we don't get 0 over 0, this is going to tell us about the vertical asymptote. So we're going to set the denominator equal to 0 and solve. 2x squared plus 5x minus 3 equal to 0. We're looking for two numbers that multiply to give us what? Two numbers that multiply to give us negative 6. Two numbers that multiply to give us negative 6 and add to give us 5 are 6 and negative 1, right? So negative 1 and 6. A times C, AC method, the same as before. A times C. So let's look at the box. So now that we have those numbers, this part should be easy. So then we're going to bring down the 2x squared, the negative 3. This is going to be a negative x, and this is going to be 6x. What do the top two have in common? What do the bottom two have in common? What do the left two have in common? What do the right two have in common? Negative 1. All right? Plus, like this. So then our claim is that the original and factored form is going to be 2x minus 1, x plus 3 equal to 0. So then what are the zeros here? What x values make these 0? So what we're saying is that there should be a vertical asymptote when x is negative 3. There should also be a vertical asymptote when x equals a half. So it looks like we have 2, which is fine. So now, if we can talk about vertical asymptotes, we can also look at what? Horizontal asymptotes. All right. So then 4, horizontal. All right. So to find horizontal, what do we need to do? We need to compare the degree of the numerator to the degree of the denominator. What's the degree of the numerator? 1. What's the degree of the denominator? 2. Is the numerator larger than, smaller than, or equal to? Smaller. So that's actually case 1 that we had in that list of cases. So that means that because the numerator, let's do it like, what color were we using? I guess I'll do this. So because the degree of the numerator is smaller than the degree of the denominator, that means y equals 0 is a horizontal asymptote. Okay, it's not obvious. You're just going to have to look that up or ask me outside of class. We only got about 20 minutes, which is fine. So now we have a horizontal asymptote. If we have a horizontal, there's not going to be an oblique or any other kind of strange asymptote. If there is no horizontal, you might have an oblique, and you might have, there are either others that we can do. Now, we talked about asymptotes. We can also do a test. We can look at symmetry. So let's look at some symmetry really quickly. If we want to look at symmetry, all we want to do is replace x with negative x and see what happens. All right? So the top, we're going to have negative x plus 1. The bottom, that's going to become a 2x squared minus 5x minus 3. If we factor out a negative from the top and bottom, we're going to get negative. We're going to get x minus 1. The bottom is going to become negative. It's going to be a negative 2x squared plus 5x plus 3. Is there any way for us to get back to the original? There's no way to get back to the original, right? So since we can't do that, there is no symmetry. So we're going to say there's none here. This is going to be the 5th thing. There's no symmetry, or none. Let's do the 6th thing. Let's do a few additional points, all right? Now, we want to, on this graph, we want to put the vertical asymptotes and any X-intercepts. Do we have any X-intercept? What is it? What's the X-intercept? X is negative 1. That's going to be a 0. Do we have any vertical asymptotes? What are they? Okay. So we got -3 and we got positive 1/2. -3 is going to be a vertical asymptote. 1/2 is going to be a vertical asymptote. So then, now, these are the key numbers. So on this, again, on this one, we put list any vertical asymptotes and X-Intercepts. Okay? So now we've plotted. We just want to choose a few additional points between and beyond all of these key numbers. Give me a number to the far left to test. So when X is -4 into the original, let's see. I'm going to do the following. Just for the sake of time, I'm going to go here to my calculator. And what I'm going to do is go to y equals, it looks like it's still healthy. The original is x plus 1 divided by 2x squared plus 5x minus 3. Nope, minus 3. Yes. Then I'm going to quit, and I want to just calculate these values. I'm going to go to variables, y variables, function, y1. Now, the first point we were testing, we said when x was -4, the y value we get is a -1/3. So that means it's below the x-axis in that interval. Give me something between -3 and -1 to test. -2 sounds good. So when x is a -2, y is a positive 2/10 is a fifth. You could say a fifth or 2/5, but it's positive. So here it was negative, which means it's going to be below the x-axis. So all of these points are going to be below over here. This is positive. The y value here was positive. So all these values are going to be above the x-axis. Give me something between -1 and 1/2 that we have not used. Because we've used what have we already used in this interval? Between -1 and 1/2. When x is what's the number between -1 and 1/2? We could do a fourth. What number have we already tested in this interval? When x is, what's a classic number between -1 and 1/2? 0. We've already tested 0. When x is 0, we got a -1/3. So I would anticipate them all to be negative. I'm just going to choose a point that we haven't chosen. So we can do the fourth. 1/4 is in this interval. So when x is a fourth, we're anticipating a negative result. So I'm going to come back here. When x is 1/4, we get a negative something. Let me see if I can hit math as a fraction. -10/3. -10/13. But what we're saying is that in this interval, all of our results are going to be below the x-axis. And then one more region to test, and then we're sitting pretty. Okay, so we still got about 20 minutes. We're actually okay. Give me a number to the right of 1/2 to test. I think I heard it very faintly. Yeah, it's 1. I mean, anything to the right is going to work. So when x is 1, let's see what we get. What do we get? Let's go back. When x is 1, what do we get? Positive result. We get a 1/2. So I just plugged all those into the original. I used the y equals. So now let's synthesize all this information. So the x values, it looks like if we go 7 or so in all directions, we should be okay. So what I'm going to do, I'm going to bookmark this. And actually, I'm going to copy. I should have kept the blank one. Is it that far back? I'll just make another one. Because I'd have to clean that other one. So I'm just going to make one from scratch. So I'm going to go here and let's copy this. And let's paste. Let's clear the page. Clear. Okay. All right. Okay. So we need some graph paper. So that's what we're going to do. We're going to introduce some graph paper. We'll come back. Paper. We got graph paper. Okay. So then we said 7 in all directions should work. So let's go ahead and do that really quickly. So then like this. I'm going to do something a little different. I'm going to start with the origin. So say this is my origin. I want to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I want to go 1, 2, 3, 4, 5, 6, 7. I want to go 1, 2, 3, 4, 5, 6, 7. Okay, so then this goes from here to here. I think this is okay. It should work. Let's go 1, 2, 3, 4, 5, 6, 7. And then this is a -1, -2, -3, -4, -5, -6, -7, -1, -2, -3, -4, -5, -6, -7. Okay, and this is the origin. All right, so then we have this. Now, let's go back to the first piece of information. We said the y-intercept was 0, -1/3. So we're going to plot when x is 0, y is a -1/3. So we're just about right in here somewhere. This is our 0, -1/3. Okay, so that's the y-intercept. Then we got an x-intercept of -1. Let me move this out of the way. I'm trying to find a good place to put it. I'm going to move it and shrink it down. All right, it should fit just about right there. Okay, so we said an x-intercept of -1. So we had -1, 0. So now we're labeling our points. Let's keep going. So we did 1, we did 2. Number 3, we got a vertical asymptote at -3.5. So when x is a -3, so let's get this out of the way. Shrink it down to size so that we can do what we need to do. So -3 is about there, that's fine. So then we're going to go, here's a vertical asymptote. Here's a vertical asymptote. And then the other one we said was x is what, 1/2, which is here. Okay? We're just piecing it together. So then we got our 1/2. So then horizontal asymptote, we said y equals 0. That's fine. Now, the horizontal asymptote, you can actually cross it. It just describes what happens in the long term. Okay? So this is okay. If this is the horizontal, we get it on the x-axis. That's fine. Y equals 0. This is x equals -3. This is x equals 1/2. This is y equals 0. So we got our asymptotes or asymptotes, whatever the proper way is. You know what I'm getting at. Symmetry, we said there was no symmetry. And then a few additional points. Let's plot these points. So we got a -4, -1/3. -4, -1/3 is about here. This is -4, -1/3. We are just about out of time. This is -4, -1/3. Then we got -2, +1/5. So -2 and 1/5 is really close to the x-axis, so we're here. This is a this is -2 and a +1/5. Then we got a +1/4 and a -10/13. 1/4 is there, and a 10/13 is about here. That's the 1/4, -10/13. Okay, and let's go like this. Here. Okay, this can happen. This is fine. And then the last one we get is a 1.5. Oh, you're out already? Oh, in the flow. All right, give me a moment. That's what they told me. This is an old pen, though. I've had it for like, I mean, I don't know how long we've been at it. We've been at it for a while, and I don't know that I let it charge for 15 seconds. But this is also an old device. Everything is old, so it's going to decrease. When I bought it, they said 15 seconds lasts 30 minutes. So this was 2012 or so when I got this stuff, something like that. Yeah. That's why I get Apple products, because actually the first Apple Mac computer I had I bought it in 2009. It lasted me all the way until like 2016, something like that. 2016, 2017. The only reason I don't have it anymore, I gave it to somebody and then it got stolen from her. She left it and broke into her place and they stole it. But it was working the whole while, going strong. So Apple, I mean, it's a good product, but now the new president or whoever the CEO is, he got some philosophies I don't necessarily agree with. He's kind of on a slippery slope with me, but they still kind of have the best product as far as I'm concerned. 1/1 and upper half, we're here. So I know it's kind of close. 1.5. Okay. So now let's bring this all together. So now if we look at this, if you look at the first part, the first one is saying start below the region. So what we're gonna do, we're gonna start close to the asymptote, pass through our point, and then finish close to the asymptote. That's it. Start close, pass through the point, finish close. So this one's saying start close over here, pass through this point, pass through that point, pass through that point, pass through that point, and then finish close. That's all that it's saying. Okay? This one is saying start close here, pass through this point, and then finish close. So the only reason it's kind of like exaggerated like that, because maybe our window was too large. Maybe if we did a window for maybe 5 in all directions, it would be a little bit easier to see. But long story short, what you just saw was the demo on how it goes. My suggestion to you, do your best, forget the rest, don't stress, and be blessed. Do your best. Okay? Do not let this discourage you. Because if you defeat yourself, then you're guaranteed to fail. So do not defeat yourself. Just do your best. Let's look at it. Okay? Because there's a lot of other things that you can focus on if you're not feeling this. They're just restating all the stuff that we did, and you see they get the similar graph. Okay? It's not trivial. It's not trivial. Let's see. The time. We got about a little over 10 minutes. I'm going to kind of breeze through this really quickly. I'm going to leave this as an exercise. You should be able to do that at this point. Because the only reason we kind of need to go ahead and finish this, because next week we're gone the entire week. So then when we come back, I'm not trying to have an exam due after the break. So when we get back, I want to start some fresh material, and then we can kind of, that way we're not trying to study over the break. That's a whole different thing. Which then you don't really get a break, and you need to get some rest. So that's why we're going to go ahead and finish this out. So this is an exercise. I'm going to leave these as exercises. We did about 3 or 4 together. If you want to see any demo on any of these, again, just email me and I can make dedicated videos. I can go at a much slower pace. I don't have to go at this rhythm. I'm going at this rhythm just because class time is precious and we don't really have a lot of class time. That's why I'll be a little bit irritable because we don't have a lot of time in here. So if I'm distracted for any reason, it's going to irritate me. So if you don't want to catch that, don't distract me because I'm kind of in a rhythm. That's the only reason. If I felt like time was an issue, I wouldn't even think twice about it. I'd just let it go. But we don't have time. So that's the only reason I'm like, hey, we gotta stay focused. It's only 2 hours at a time. We talked about all this. I'll let that be. So that'll come out like naturally. The slant, I know we didn't work an example together, but we can talk about it. So the whole or discontinuity occurs whenever we get a result that gives us 0 over 0. So that occurs when we get 0 over 0. Can you see something here that's going to give us 0 over 0, an x value? When x is equal to 2, right? If we plug 2 into the top, we get 0. If we plug 2 into the bottom, we get 0. So that means when x is 2, there's going to be a hole or a gap in the graph. See it right there? Okay. Okay, so I'm going to leave the rest of this as an exercise. I think we're okay. Yeah. Okay, so let me stop this. Before I stop the recording, any questions, comments, or concerns before I stop? Okay. Let me go ahead and make this announcement while it's still recording. Go ahead. I'm going to put it up right now. As soon as I stop recording, I'm going to load the PDF. Yeah, I'm going to load it before, like in a matter of minutes. So we got through 3.5. There's still one more section. I think there's still 3.6. So you're responsible for that. Now there are videos on Moodle that pertain directly to that. Watch it and take notes as normal. What I plan on doing, I'm going to make my other class responsible. They're going to have to watch the video for 3.4 and 3.5 that we did together. I'll do 3.6 with them. I don't know. I got to think about this because they're not going to, if I start with 3.6, they're not going to know everything. So I'll do the best that I can. I still might do it and we'll make a decision. But on Thursday, you guys we're going to be taking 2 exams. So exam over chapter 2 exam over chapter 3, and then you're off for the break. I would say anticipate about 12 questions per exam. I'm open to the idea of you can miss two questions on either exam. Like if you're taking exam 2, I'm open to the idea of you can miss 2 questions and still get a perfect score. So you can miss 2 questions and still get a perfect score. Pardon? Yeah, I would say that's fair. 12 questions on each exam. You're responsible for 10 questions, all multiple choice. Okay, so it doesn't get much lighter. Also, it shouldn't, if you know the study guide, you should be okay. You can include that in your notebook. Nobody ever said that you can't include that. Is it coming together? So if you go ahead and just do the study guide, have it ready to go at a baseline. I'm not guaranteeing that it's going to be the same, but at a baseline, you definitely want to have the study guide completed and have it ready to go on the exam. Okay? I've been doing it for a while and students still don't catch on and they kind of give up. I was like, no, if you listen to what I'm saying and do it, you'll see it's really not that bad. I'm kind of cutting you a break. I'm really cutting you a break. Because when you get to, like, for another institution where you have more time, you're not going to get these kind of breaks. They're going to say, oh, the exam is over chapter 3, and they're just going to start talking. You'll be lucky if they answer questions for you. And then you're going to have an exam, and that's it. But we're not going to do it like that. We don't have to do that. So exam 2 over chapter 2, exam 3 over chapter 3, we're going to do them twice on Thursday. Questions, comments, or concerns? Okay. So we got about 10 minutes. Let me stop the stream. So we're going to stop.